An example for the goodness of fit test. We have 180 teachers that have been evaluated using method 1, method 2, or method 3, and they were asked which one do they feel is fair. So 63 rated method 1 is fair, 45 rated method 2 is fair, and 72 rated method 3 is fair. And now we want to know, is there a difference between the frequencies of these methods? Right? Each level has the equal probability, so there's 3 levels, method 1, 2, 3. So there's 1/3 chance, and if we have a frequency of 180, the proportion is 1/3, so the expected frequency is 60 for each category. 180 divided by 3. So now what we're going to do is we use this formula here for the chi-square goodness of fit test, which is the observed frequency minus the expected frequency squared divided by expected frequency, and then we calculate the sum of all these cells. So the first category method, we had 63 minus 60 expected squared divided by 60. So this would be 3 squared, 9 divided by 60. Then we add, this was this term, right, one term, so we do this, the sum, so we add the next category. Method 2 was mentioned 45 times as fair, minus 60 would be a 15-point difference. 15 squared is 165 divided by 60, and then plus the frequency of the last method, the third method. 72 minus 60 is 8. 8 squared is 64 divided by 60, and all of these added up give us a chi-square of 6.3. So that's the chi-square difference value here, 6.3. Now the next thing that we need to figure out is our probability of obtaining such a value. Here you can see a table that spells it out what I just explained. So to determine the significance, either we calculate the probability directly with Excel or SPSS, or what you can do is look it up in a table. So in this case, it's the degree of freedom is K, the number of levels, number of categories. So in this case, 3 minus 1 is 2, so 2 degrees of freedom. And if we look it up in a table, we get a critical chi-square value of 5.991. So that's here, right? So 5% of this whole distribution is on the right of 5.991. So this is our line in the sand. If a chi-square value is larger than 5.991, we would assume that it's a really unlikely event, right? There's only 5% of the values that are in this area here, and thus we would reject our null hypothesis. We would say there is a statistically significant difference between observed and what we expected. Right? If we would have had a 1% significance level, right, we would again go to degrees of freedom of 2. That critical chi-square value for the 1% significance level would be 9.21. Right? So it's way out here. So you could see with the 6.3 that we calculated, we are in the 5% significance level range, but we're not even close to the 1% significance level.